yj. This is a vector, this is a vector. Sum of the two vectors is given by this. So x, xi, this is here to here xi, here to here xi, here to here yj. This plus this is equal to this. So for a plane we write like this. If the point is in space, it will have, in addition to the two coordinates, it will have z coordinate also. Then you write r is equal to xi yj plus zk. So in this way you write. Now let us take a vector. A vector. A vector is shown as, you take any vector, it will have x component, y component and z component. So for position vector, this is the x component. Similarly, for A, I write here AXI. That is x component of A plus AYJ plus AZ. Okay. Like this. So it's x coordinate, this is x coordinate, this is y coordinate, this is z coordinate. In this way we write. Similarly, suppose B vector is there, you write BXI, BYJ plus BZ. Okay. In this way we write. Okay. Now let us find A dot B. A dot B. So this multiplied by this. Is equal to by distributive properties, first multiply this by this vector ax bx I dot I plus only with this only I am multiplying the three terms ax by I dot j plus ax bz I dot k. Now let us choose ay bx ay by ay bz. Next az bx az by az bz. Here same thing comes. So here j dot I j dot j j dot k k dot I k dot j k dot k. So now is equal to I dot I. So already you know I dot I or j dot j, I dot I. So the angle between these two is I dot I means 1 into cos 0, 1. J dot j also 1, k dot k also 1. So this gives 1 value, this gives 1, this gives 1, and this also gives 1. What about I dot j? This is along x-axis, this is along y-axis, both are at 90 degrees, and cos 90 is 0, so this becomes 0. These are at 90 degrees, 0. J and k, y-axis, z-axis, 90 degrees. K is j at 90 degrees. Ki at 90 degrees. Ji at 90 degrees. So what is remaining? Only 3 terms are remaining. I dot I is 1. J dot j is 1. K dot k is 1. So here you ax bx plus ay by plus az bz. So like this you get here. So you need not do all this. We got formula. Suppose a vector is given, b vector is given. Just what all you have to do is you take the product of first x components plus you take the product of y component plus you take the product of z components. That's all. See, we have taken a vector 2 times. Now scalar product of a with a, product of x components, product of y components, product of z components, ax square plus ay square plus az square. A dot j is equal to okay. Now so actually there is a definition. According to definition, let us find. See, what is the definition? A dot b is defined as ab cos theta. So this is the in this way scalar product is defined. No? So let us write a dot a. First what we take? Its magnitude. So its magnitude is a. Its magnitude also a. Cos. Angle between these two 0 because same no 0. Cos 0 value 1. So a into a square. A into a square. So this is second equation. See, you see first and second equation. On left hand side a dot a. So this is equal to this from 192 we get like this. Or a is equal to under root ax square plus ay square plus az square. That is, if you want magnitude of a vector, what all you have to do is you take the sum of the squares of the x, y, z components. Afterwards you find its square root. That's all. In this way you can find its magnitude. Similarly, suppose b magnitude you want to know. B is equal to bx square plus by square plus bz square under root, like this. In this way we find the values. Now we are discussing the properties of scalar product. A dot b is equal to AB cos theta. Now tell me, when A dot B, when scalar product gives maximum value and when it gives minimum value. So if you look at the equation, of course its the magnitude of A, magnitude of B will be constant. When you come to here, theta value, so its value depends upon A, B as well as theta. So here, if A and B are constant, then it depends upon theta. If you give different values, for example theta is equal to 0, cos 0 is equal to 1, maximum value. Therefore, at theta is equal to 0, scalar product gives maximum value. You can write A dot B gives, or scalar product of two vectors gives maximum value when theta is equal to 0. Theta is equal to 0 means both are in same direction. So when they are in same direction, scalar product gives maximum value. What if theta is equal to 90 degrees? Cos 90 is 0, minimum. What if theta is equal to 180 degrees? Cos 180 is equal to minus 1. So this is first quadrant, second quadrant, third quadrant, fourth quadrant. But we will be considering only these two. Suppose two vectors can be like this. This is A vector and this is B vector. They can be like this, or they can be like this, or they can be like this. Here angle is 0, here angle is 30 degrees, here angle is 90 degrees, and the two vectors can be like this also. Here theta is equal to 120 degrees, and the two vectors can be like this also. A vector, B vector, 180 degrees. So in the first quadrant, theta is between 0 and 90 degrees. So when angle is between 0 and 90 degrees, then cos gives positive value. So scalar product is positive. If angle is between more than 90 and less than 180 degrees, here the scalar product is negative. Now let us do this problem. Find the angle between force and displacement. Also find the projection of F on D. Okay. F is given, force vector 3I plus 4J minus 5K. So actually it can be written like this: X component, Y component, Z component. Similarly, D vector is given dxi plus dyj plus dzk. So here what we get, first let us note the data. Solved example 6.1. See here, F is given, F component wise given. Now displacement vector given. So what is asked now? So given. What is asked? Number 1, theta, angle between the two vectors is asked. Still what is asked? Also find the projection of F on D. It means, suppose this is D vector, this is F vector, this is the angle between them. So what is asked here? Projection of F on D. This is asked. Projection of F on D. It means what is this? This is nothing but F cos theta. If this is F, its adjacent side will be F cos theta, and opposite side will be F sin theta, that you already know. So F cos theta is asked. According to scalar product, F dot D is equal to FD cos theta. So first let us take LHS. F dot D. F dot D is nothing but fx dx plus fy dy plus fz dz. See, previously we have written, see, what was that? See, here we have found that, what was that? We have calculated A dot B. A dot B is equal to we did the lengthy calculation. So for A dot B, what result you got? That is equal to, these are the remaining. So A dot B is equal to AX BX plus AY BY plus AZ BZ. That's product of X components plus product of Y components plus product of Z components. Here also F dot D means product of X components, product of Y components plus product of Z components. Fx dx, here fx is, see, it's 3 into 5 plus 4 into 4 minus 5 into 3 . 60 we got. So next on RHS, F is there. See, F is a magnitude of F vector. How magnitude is defined? F is nothing but square root of fx square plus fy square plus fz square. See here, x component 3, 4 square minus 5 square 9, 16, 25 root 50. Now next D. D is equal to dx square dy square dz square under root. So D vector here 5 square 4 square 3 square. So we got 50 root afterwards. FD cos theta. That see, now the first equation. Let us write cos theta is equal to, take FD to left hand side, F dot D by FD. F dot D value you got 16. F value root 50. D value also root 50. Root 50 into root 50, 50. So now cos theta is equal to 16 by 50, or theta is equal to you take the cos this side, cos inverse 16 by 50. So you got one answer. Next, what we have to find? F cos theta. F value and cos theta value here in 16 by 50. So next on this is second one. F cos theta. F value root 50 and cos theta value 16 by 50. That is equal to 16 by root 50. This is another answer. Next, work done by a constant force. It is defined as scalar product of force and displacement. So W is equal to F dot D, that is equal to Fd cos theta. Now, when the conditions under which no work is done. Conditions under which W is equal to 0. That is asked next. When work done is 0. See, looking at the definition, you can say one option, if F is 0, then this becomes 0. Second option, if displacement is 0. And third option, if the angle is 90 degrees, because cos 90 is 0. So in the three cases, the work done will be 0. We can have some examples. For example, let us take example for F is equal to 0. See, this is floor. On the floor, you are moving a block, applying some force. Suppose this is smooth plane. Smooth means mu s is 0, frictionless surface. That is, if you are moving to right hand side, generally frictional force works in left hand side. But since this is smooth surface, force of friction is 0. If anybody asks what is the work done by the friction force, you say you have chosen smooth plane, therefore work done by the friction is 0, because force itself is 0. Okay, now let us choose this one. Displacement is 0. See, if you apply some force on a wall, the wall doesn't displace. There the displacement is 0. Even though you apply 10 newtons of force, 14 newtons of force, since the displacement is 0, work done also will be 0. Next, theta is equal to 90 degrees. For example, on this block, gravitational force is working. Gravitational force is always in vertical direction downward. See here, you are pulling in this direction, that is, it is displaced in this direction. See, this is the displacement. This is force vector, this is displacement vector. So to displacement vector, gravitational force is at 90 degrees. 90 degrees. So if anybody asks what is the work done by the gravitational force, you say 0, because this is making angle 90 degrees with the displacement. Next, work can be positive as well as negative. Work can be positive as well as negative. For example, this is floor. Here an object is there having some mass. Suppose you drop the object there. Under the action of gravitational force, it is moving downward. So gravitational force and displacement both are in the same direction. So in this case the angle is 0. So W is equal to FD cos 0 degrees 1 value. So FD positive, you got. From 0 degrees to 90 degrees, work done will be positive. But from 90 degrees to 180 degrees, the work done will be negative. Now, let us do Can you see the problem? Additional problem 6.2, page number 142. Let me write the data. A body of mass 2 kg. Initially at rest, moving under the action of an applied horizontal force 7 newtons on a table with coefficient of kinetic friction. Compute A. Work done by the applied force in 10 seconds. Work done by applied force means capital F. Applied force. In 10 seconds. Work done by frictional force in 10 seconds. Work done by net force in 10 seconds. This let us do. This is table surface. Block is there, 2 kg. Applied force, horizontal force. Here the coefficient of friction is 0.1. That is, this is a rough surface. So work done by applied force in 10 seconds. First of all, how to calculate work done? See, by definition, work done is equal to F dot D or FD cos theta. This is the formula. Force is there, 7 newtons. D, displacement. Displacement not given, theta. Let me write here, F is equal to 7 newtons. D we don't know. Theta. Theta means, see, since this is a horizontal plane, force and displacement in the same direction. Therefore, the angle between the two vectors will be 0. So, theta is going to D. Displacement must be found out. To find displacement, we use one formula. See, S is equal to ut plus half at square, kinematic equation. So, in this again, u initial velocity 0 given, it was at rest. T in 10 seconds, here I did not write. Work done in 10 seconds. 10 seconds. T 10 seconds. A not given. See, we have to find A, no? Okay, how to find A? Now, if you are pulling the block to right hand side, if you apply force to right hand side, frictional force arises to towards left hand side. Now, net force on the body, F net. See, it is moving to right hand side, so this force is taken positive, opposite force is taken negative. So this is the net force. Now, external force F value given 7 newtons. Frictional force not given. But frictional force can be calculated by law of kinetic friction. This is Fk. Fk is equal to mu Kn. And on the block, this is gravitational force. And this is normal reaction. When the block is placed on the horizontal table, then N is equal to mg. Now let us find mu k given 0.1, m value block 2 kg, g value let us take 10, so 2 newtons. Okay, so capital F. So now let us come to this. Net force is equal to, applied force is 7 newtons, kinetic friction is 2 newtons, and here F net according to Newton's second law, F is equal to ma is equal to 5. Let me write here, F net is equal to 5 newtons. Okay. you got F net is equal to 5 newtons, but by Newton's second law F net is equal to ma. Mass of the block is 2. A is equal to 5 by 2 meter per second square. First equation, second equation, sorry, this is first equation, this is second equation, here you got third equation, here you got fourth equation. Okay, now acceleration, see here, to find a displacement u, t and a is required, and that a we have found. So let us substitute the values into and find the displacement. Substitute values into s is equal to 0, 10 plus half a 5 by 2 t square. T means 10 seconds, 10 square. So 5 by 4 into 100, (125 meters). So displacement. Now let us see the first equation. To find work done, if theta d value just now you have calculated. Displacement 125 meters. So substituting values in first equation, work done is equal to ft cos theta. For applied force 7 newtons, displacement 125 meters, angle 0, 1. So 875 joules. So for the first one, for the which one, this is work done by external, work done by applied force, this work done by applied force. Now B, work done by frictional force, that will be F d cos theta. F how much? Fk, frictional force. Fk value we got 2 newtons. Here we got Fk value 2 newtons. So 2 newtons. D value, displacement, that is 125 meters. And theta is equal to 0. Sorry. Here angle between F and D. See here, F is to left hand side, D is to right hand side. The block is displaced to right hand side and friction is working to left hand side. The angle theta is how much? 180 degrees. And cos 180 degrees is equal to -1. So work done is equal to 125 minus 1. Minus 250 newtons. Minus 250 newtons. See, work done can be positive and negative also. If the angle is between 0 and 90 degrees, it is positive. If the angle is between 90 and 180, it is negative. Now, work done by net force. Here you calculated net force, how much you got? 5 newtons. Okay. But, so net force magnitude, okay, 5 newtons. Okay, let me write, see where, let me write here itself. Here itself, let me write. Work done is equal to F net d cos theta. F net is 5 newtons. Distance 125 meters. Cos theta. Theta. See, F net, it's a direction. In which direction it is? See here, on this block, in this direction is frictional force, in this direction is